Hi everybody, good morning. I'm doing industrial intrusion CTF. It's part of TryHackMe room. It was starting Friday and finished late in Sunday. They deactivated Nonce to do their checking for the leaderboard. I'm doing now Task-20 CRC me if you can. They give us two cipher binary files, cipher1 and cipher2. The room description says 3 months after Virelia Water Control Facility was breached, OT traffic is finally back online, supposedly fully remediated. During a routine audit, Black Echo Red Team intercepted two back-to-back telemetry packets between a pump controller and the SCADA server. Curiously, both packets were encrypted under AES GCM. This is a key here, using the same 16-byte nonce. That's the problem using the nonce. The first packet is just a regular facility telemetry. The second contains a hidden sabotage command with the kill switch flag. Your job is to recover the flag and stop the attack. Each file they tell us this first 16 bytes are the nonce, and the ciphertext is the 96. So we're more interested with this one, and then this the text. So we need to only take this one from the file we have. We know that the first plaintext 96 is the facility standard telemetry string. So they give us the first text, plaintext. The second part follow the same format but carry the kill switch command and flag. We need you to decrypt the content of the cipher2 binary so that we can recover and disable the kill switch. Now, a quick recap about this. So, for example, AES GCM, they tell you encryption. So we have a cipher as plain text, but the key stream here we're using the same nonce. So what happens now if you have same nonce plus key is same key stream? When the same nonce is used, so we have, for example, ciphertext 1. If you use the plaintext 1 with a key, where the key is the key stream, so we have the same keys here, C1 and C2. When we XOR a ciphertext, for example, C1, C2, if it means P1K and P2K. So because in XY we can do that, so the P1 cancel each one, and then the K cancel each one, and we have C1 C2 XY equal P1 XY P2. So now if we know one of them, for example, if we know the P1, so each binary file, as we said, we have the first one is the GCM nonce, we have ciphertext, we have, so for us we take in this part, and then step 2 data process, extract ciphertext from both file, bytes 16 and 11, so we have that, we need to do this, and then XOR C1 C2 equal P1 P2, and then we get the text we're looking for here just now. The plain text we have P1, we have it, is this one, we have this P1, and we can just XOR it to C1 C2, because C1 and C2 we already know them. So now how to start? Now, for example, here is what we have. For example, we have the cipher 1, cipher 2. I can do it manually here if I want. This is the hex value for cipher 1, but remember I don't need the first 32, because we have bits of I don't need the first 30 bit, and I don't need the last ones, so I only need this one. I only need this cipher from 16 to that's bytes. So which one to do? Now let's do it. We can use Python script for this, or we can use CyberChef, for example. I can, for example, upload my file as cipher1. Now I can just say to hex value, I don't want space, and I said drop remove. Remember we said we need to remove that because they say in the 96 the first one is the 16 bytes, so it's 32 bit, so I need to drop bytes but hold on a minute. This is the hex. So I'm working in hex, so I need to do the 32, not 16. It's a hex value. It's from hex, and I need to take, I think that's 32, not 16. We'll see if we take bytes to 90, 96. 96 is 192, 192. So this one should be the first one. That's the let's go back. So we have, this is a C1. This is our C1. Now if I remove this and just load the seat, the second ciphertext, so this is the C2, this is the second one. So I can come here, and I'm not sure if ciphertext can do, so this is the C2. And then we know the text, we have this one. So we can remove this. That's the text. I need to convert it to hex, for example, and remove the spaces. So this is our text. So with the plaintext we know it, so we just need to do P1, which is the plaintext we have, so we can kill that one. We can do from hex. We need to tell him it's a from hex, otherwise will not work with it. From hex, I need to get XOR. No, before we do this, we need to XOR these two, so we can do this one, XOR now. Before we do that, that's my mistake I did. We need to tell him it's from hex, otherwise he messed it up. So from hex, we XOR these two, so C1, C2. So let's put that, and then convert it to hex, no space, none. So this is our value now. So this is C1, C2. Let me copy that, it's easy to understand. This is C1, C2. Now we just need to do a P1, which is this one. So we have this P1, so we can just copy C. We can now, we need to XOR it with so we have P1, we XOR it with this C1, C2. So C1, C2 to cancel, so we can come back here, and then to we don't need to hex now, we just need to convert it. And now you got the kill command, and that's your flag. So that's exactly how you can solve it. So basically it's just a simple math idea that P2 is P1 XOR C1, C2. So you have C1. C1 is the data we need to create. We just need to where is it? Because they tell us to take 96 bytes, so it's in 192 bits. So you just take that, and you get the result C1, you get the result for C2, and then of course you need to XOR both of them, and then you have a text in hex, and then XOR, and you get the result. Of course, if you want things, as I said, you can see now this is there, or you can just have a Python like God Gemini to write it if you want to do automatic things. This is automatic things, of course. You take from 16 to 112, so you take the 96 byte. So this one, if you just run it, so Python 3 p.py, this one will work straight, and it give you your flag. And yeah, so that's that. So if you want to do that, I hope guys you like it. If you have a question, let me know. And yeah, this is simple, straightforward cipher. Thank you very much, and have a good day.